Okay, is it going? Good. All right, you guys, in every chemical reaction, we so far have been talking about chemical bonding, and you know that we take two or more elements and we put them together to form a new substance, right? When they combine, that's called bonding. And so in every chemical bond, there's energy. And so in a chemical reaction, so in every chemical reaction, the energy in that chemical reaction is stored in the chemical bonds. In every chemical reaction, chemical energy, I guess, energy is stored in those chemical bonds. What does that mean? It means that energy in a reaction gets absorbed and released. Well, from where? From those bonds. Okay, a chemical reaction starts with reactants. Whatever I start with is called the reactants, and then the reaction occurs, and that makes products. I start with the reactants, I make the products. And so just as an example to help you visualize, you guys, if my reactants, if what I start with is a car built out of Legos, okay, my reactants, what I'm starting with is that car built out of Legos. And I don't want that anymore. I want a motorcycle built out of Legos. What do I have to do to the car?
Destroy it.
Yeah, I gotta take it apart, right? So you guys, in the reactants, in a chemical reaction, that's like my Lego car. And so what I have to do with the reactants is I have to break the bonds. I have to take them apart so that I can rearrange my substances into something new. So if I'm breaking things apart in the reactants, what am I doing in the products? Putting them back together, guys. Yeah, I'm forming new bonds. Okay, so if I break things apart in the reactants, I take it apart so that I can put them back together in some different order. I'm forming new bonds. In order for that to happen, do I need lots of energy or not very much energy to take things apart? Lots. Think about this in terms of a real house, guys. If I decide I don't like my house anymore, and so I'm going to tear it down and build a new one. If I'm going to tear my house down, I'm going to need lots of energy, right? It's hard to swing a sledgehammer, yeah?
What if we just buy like the machine?
Okay. So, to break bonds in the reactants, a reaction has to absorb energy. It takes a lot of energy to break things apart. But then in the products, if I'm going to form new bonds, guys, so now I've got my house all torn down, is it going to take me a lot of energy to build my new house?
Yeah.
Do you want to know why? Because I'm just going to pay somebody to do it for me.
Why don't you pay somebody to take it down?
Okay? Because I was trying to save a little money, so I took it down by myself. Okay? So you guys, to break something apart, energy has to go in. It takes a lot of energy to break something apart. But then, you guys, to form new bonds, it's going to release energy. Why? Because I'm going to sit back and pay somebody to do it for me. Okay? So in a chemical reaction, energy has to be absorbed. Energy has to be taken in to break things apart. And then it releases energy when new things are forming.
Can I build your house?
All right? I'm not really going to tear my house down. Okay. Sometimes a reaction absorbs a certain amount of energy, and then it releases the same amount of energy. And if that happens, great. Nothing happens in the reaction. But in other reactions, more energy gets absorbed than gets released. Or less energy gets absorbed and more energy gets released. And you guys, when the amount of energy absorbed and released isn't equal, you're going to have a change in temperature. And that gives us a special kind of reaction, and these are called endothermic reactions and exothermic reactions. an endothermic reaction and an exothermic reaction. What does endo sound like?
Endoskeleton.
Okay, endoskeleton, inside, in. What does exo sound like?
Outside.
Outside. Exterior, exit. Okay, so you guys, in an endothermic reaction, more energy is going to go which direction? In. And in an exothermic reaction, more energy goes out. So in both reactions, energy gets absorbed in the reactants and energy gets released by the products. To determine what type it is, it's whether more is going in or out. So in an endothermic reaction, it absorbs more energy in the reactants. To do what? What happens in the reactants? What's happening to the bonds? They're breaking bonds. I got to take stuff apart. So in an endothermic reaction, it absorbs more energy in the reactants to break bonds. It's still releasing energy from the products when it's forming new bonds, just not as much. So you guys think about this. If I am holding this reaction in my hands, okay, we know that it's going to absorb more energy. If it's absorbing energy from my hands, it's taking energy from my hands, how are my hands going to feel?
Cold.
Cold, because it took the energy from them, right? So in an endothermic reaction, guys, that's going to feel cold. That's going to feel cold because it's taking the energy from those surroundings. In an exothermic reaction, an exothermic reaction releases more energy from the products to form new bonds. And think about this. Answer that. Say student speaking. Okay, it releases more energy from the products to form bonds. So if you're holding it in your hands and it's releasing more energy, it's putting energy into your hands, how are your hands going to feel?
Warm.
They're going to feel warm. So you guys, exothermic reactions, they feel hot. All right, as an example, you guys think about this. If I take an ice cube and I put that ice cube in my hands, what's that ice cube going to do? It's going to melt, correct? Well, in order to melt, it has to absorb energy, yeah? If I'm holding it in my hands, it's absorbing energy from my hands. How do your hands feel?
Cold.
Cold. Okay, if you turn on the stove and you hold your hand over the burner,
Why would you?
Not on the burner, over it.
thank you, not on the burner, over it. You're holding your hand over the burner, and so that burner is releasing energy to your hand. How does your hand feel? Warm, hot. That is exothermic. Question.
That had to be said because, I bet one person.
Just don't touch the stove. All right, hey, listen up, guys. Okay, if I have a chemical reaction, and let's say that at the start of that reaction, I measure the temperature of that reaction, and it is 25 degrees Celsius. And then that reaction occurs, and it does whatever it's going to do, and then at the end, I measure the temperature again. Now the temperature is 40 degrees Celsius. Did it get hotter or colder? Hotter, which means this is what type of reaction? This is an exothermic reaction. I have another reaction, and it starts at 40 degrees Celsius. And then the reaction happens, and I measure the temperature again at the end. And now the temperature at the end is 30 degrees Celsius. Did it get hotter or colder? Colder, which means it's what kind of reaction? An endothermic reaction. I have one more reaction. And this reaction started at 30 degrees Celsius. Then the reaction occurred. I measured it. And it's still 30 degrees Celsius.
Endo exo.
Neither.
Neither.
Yep, it's neither one, guys. Does this mean that a reaction didn't happen?
No. Because one
Does it mean that energy wasn't absorbed or released?
It fluctuated.
Okay,
It means that
it was the same amount, exactly. Whatever energy was absorbed to break the bonds was also released to form the bonds. So since the same amount was absorbed and released, don't put that away, we're not done. Since the same amount was absorbed and released, the temperature did not change. Okay? All right, finally, guys, we have this thing called the law of conservation of energy. And actually, I lied. I don't want to talk about that. Where does the energy come from for the reaction? When energy gets absorbed, where does it come from?
it's surroundings.
Yeah, the surroundings. You said outside. Yeah, it comes from outside the reaction. When the energy gets released, when the energy gets released, where does it go?
Outside.
Out to the surroundings. And so when it gets absorbed from the surroundings and released to the surroundings, now I want to talk about this law. There's this thing called the law of conservation of energy. The law of conservation of energy. And I thought you guys had learned this last year, but apparently you didn't. Okay, the law of conservation of energy says that energy can't be created or destroyed. Mm-hmm. Some of you maybe learned it. Energy can't be created or destroyed. It can be transferred. And I'm going to put or converted, because it could be converted into other forms, which we will talk about later this year. Okay, so energy can't be created or destroyed, but it can be transferred. So what in the heck does that mean? That means that however much energy you start a reaction with, between the reaction and the surroundings, you've got to end up with that same amount. Okay, so if I start, you guys, energy is measured in a unit called joules. Okay, that's Joules. So if my reaction has 50 joules and the surroundings have 50 joules, how much total energy do I have? Got 100 joules, right? So if this reaction happens, and now in my reaction I have 30 joules of energy, how much energy is in my surroundings? 70, because my total has to be how much? 100. Okay, if my reaction occurs, and now my reaction is at 80 joules, what do I have in my surroundings? 20 joules, because the total has to be 100. Okay, law of conservation of energy says that it can't magically appear or disappear. It can just get transferred from one place to another, but your total amount will always, always, always stay the same.